All right. So Chad kind of went over the call stack today and recursion, but just kind of want to reiterate. So what is the call stack? A stack is a type of data structure. We kind of went through that. There's a stack, there's a queue, there's a bunch of different data structures. So the call stack stores executions of code on the stack in the order that they are executed and removes them from from the stack when they are done executing. So like if one function starts executing and then this function calls another one, then this second one gets put on the stack. And then when this one's done, the top one pops off. And then once that one's done, then the bottom one pops off. So it's a stack. Is it FIFO, first in, first out? No, it's a last in, first out. So it's a LIFO method, if anybody understands like accounting, last in, first out. The last one that starts is the first one to be done executing. So here is just like a visualization of the call stack. So over here, I don't know if, can you all see this? Yep. So we have got three functions, one called main, one called second, and one called third. The main function just console logs main starting and then calls the second function, which is down here. And it just passes in two arguments, just numbers, doesn't really do anything with those numbers. So it passes in two numbers. And then the second one, inside the second function, it console logs second starting. And then inside the second one, it also calls the third function, which doesn't take any arguments. It just console logs third starting. And then it returns third removed from the call stack. The second one returns second removed from the call stack. And the main one returns main removed from the call stack. And then down here in the very bottom left-hand corner, we actually are invoking the main function. So this is just a quick visualization. Here's the call stack. So when I execute main, it initially gets put on the call stack. So the main function is executing right now. And then can anybody tell me what's going to happen? What's next that's going to be put on the call stack?
The second function.
The second function? What's happening before the second function is called?
The console.log.
Yep. So the console.log is another function. It's literally just console.logging something.
Oh, okay. That's a function.
Yep. So the next thing, the console.log is put on the call stack. What's going to happen next?
The second function's added to the stack.
The log's going to come off.
Yep. Thank you. The console log just executes and then stops executing right away. So then the console.log gets taken off the stack, and then the second function gets put on the stack. So now we're in the second function. So now the console log is going to come on the stack, console log starting. And during this entire time, the main function is still executing. It's still running because it hasn't hit the return statement yet. And it won't hit the return statement yet until all these other functions stopped executing. So the console log starts, gets taken off the stack. So we're right here. The third is going to be put on the stack. So now we're down here in the third. The third is starting to execute. And then the third console log, third starting. And now once we're done, it says we return third removed from the call stack. We're not console log anything. So once it hits the return statement, it just stops executing. So the console log third starting gets removed from the call stack. Now it comes into the return. Now the third is done. Now we come up here. Now right here, the third is done executing. Now it's going to jump down to the return statement or the return of the second function. So then the second function gets returned from the call or removed from the call stack. And then finally the main. So right here, the second is just now done executing. Now it jumps down to the return statement. And now the main function is removed from the call stack. Does that visualization kind of help with regards
So
to
is this visualization just to help us understand the call stack within VS Code. You wouldn't use this in a program, would you?
So yeah, essentially the visualization is just to understand what's happening on the call stack, whether it's in VS Code, whether it's in the browser, whether it's even in your code. Like there's an execution stack that's always being run, and there's ways in VS Code to visualize that. I know Chad showed you, I think yesterday, or not yesterday, a couple days ago or last week. There's also a way to show it inside Chrome browser. Yeah. So, and this is when we get to recursion, because here's a main is a function that calls another function. Second is a function that calls another function, and so on. Where recursion is a function that calls itself. And again, using recursion to solve a problem requires two cases: the base case, the condition in which the function stops calling itself, and the recursive case, which is the case in which the function returns itself. So for example, every time I write a recursive function, I'll literally put comments out inside my code. I'm just going to say comment out base case and recursive case before I even define them, just because I know I'm going to need a base case and a recursive case. Because a lot of times people forget to write the base case, and that's when you get into the maximum call stack exceeded, and then your kind of code breaks or your program stops working. So always just make sure you have a base case and a recursive case. So here is a function called sum up to, which takes in a number, and you're going to like sum up to that number. Take the sum of every single number up until that number. So for example, 3, if we had 3 in here, it'd be 1 plus 2, which is 3, plus 3, which is 6. So the sum of all those together is 6. And the base case for that, if the number is 1, we just return 1. Else, we return the number, so 3 plus, and this is where we call the function itself again, the number, which would be 3 minus 1, which would be 2. So we're passing in 2 in here. And here's like a quick visualization of the function of sum up to 5, where we're passing in 5 into the function. So here's the initial function. We pass in 5, comes into here. If 5 equals 1, we return 1. No, that's not true. So it jumps down here into the recursive case. Then we return 5 plus sum up to 5 minus 1, which is 4. So now we execute this function. Pass in 4. Is 4 equal 1? No. It's going to jump down to the recursive case. Then it returns 4 plus 4 minus 1, which is 3. So we're executing this down here. Is 3 equal 1? No. Goes into the recursive case. Sum up to 3 minus 1 equals 2. So we're down here. And I ran out of room here. So is 2 equal 1? No. It jumps down here in the recursive case. Return 2 plus 2 minus 1 equals 1. Comes over here. We're passing in 1. If 1 equals 1, we just return 1. We stop executing this function, and it kind of like a cascading effect. This one stops running. This one stops running. This one stops running. This one stops running, and this one stops running. So we end up getting 5 plus 4 plus 3 plus 2 plus 1, which I think is 15. Does that kind of make sense visually? No? Kind of?
Yeah, it does.
Cool. Does anybody have any questions about recursion? Two things that you need: a base case and a recursive case. Can't emphasize that enough. All right. Does anybody have any questions about recursion? Nope. Let's actually do a couple. You want to do a couple?
Sure.
Go. What do we got? Go. Just gonna open up. let's see. I'm going to do make directory. Like doing SpaceX. Or we can do JS or Python. All right. So can everyone see my screen? Good. So everyone knows, who doesn't know what SpaceX is?
I'm a huge SpaceX fan.
Likewise. So if you don't know, like after like, I don't know if it's 1 minute or I think it's after 1 minute. So right before they take off or launch the rockets, once the countdown, like 10 minutes, 5 minutes, 4, 3, 2, 1 minute. Once 1 minute of the SpaceX countdown, there is no manual interruptions in the countdown. A computer takes over and starts counting down. And if and it monitors a bunch of systems, and if any systems are out of whack, then the computer will abort the launch. But at that point, the computer takes over. So the computer is literally counting down. And there's a couple ways we can count down from like 1 minute down to liftoff. We can do it iteratively or recursively. So in here, I'm just going to do an iterative example, and then we'll do a recursive example. So I'm just going to say like SpaceX countdown. That takes in a number and it counts down from like say 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then it returns liftoff, and that's when they lift off. So if I wanted to count down from an input given number and just like print it to the console, it's not that big of a deal. So I can just use a basic for loop or a while loop depending on what we want to do. So I can just say for what do we say? For num in, why am I drawing a blank? I'll do a while loop. While num is greater than 0, print num, and now I can do num equals num equals num minus 1. And then at the very end, I can just return liftoff. So if I wanted to execute this, let's see if I even have it to work. So it takes in a number, let's say 10. Well, 10 is greater than 0. It comes into here, prints 10. Then it reassigns num to 10 minus 1, so 9. Then it comes up here, prints 9, 8, 7, 6, 5, 4, 3, 2, 1. And then here, so once it gets to 0, it breaks out of this while loop, and then it says liftoff. So if I do Python, SpaceX, there we go. Can everyone see that? Let me look at something else. Oh. Cool. So if I wanted to convert this to a recursive function, so if I commented that out and did def SpaceX countdown, takes a num, and this is going to be the recursive. Oh, what's going on? I don't want you. Oh, wow. And this is the iterative. What the hell? Iterative. So what's the first thing we need? Base case and a recursive case. What would be the base case for this?
when x or num equals 0.
Yep. So I can just do an if statement when, or if num equals 0, return this liftoff. Else, what do I need to do? Return a recursive case. I need to return the recursive case. So I need to return space x countdown. But now I want to decrement number instead of 10, I want to be passing in 9. And in order to do that, I can just do num, which would be initially value is 10 minus 1. So now the value I'm passing in is 9. But before I do that, I just want to print num. So if I execute that now, I get the same thing. So it says if num equals 0, liftoff else, essentially, I could use an actual else statement if I want, but it's not necessarily required because if it is a return, it will come into here first and return it before it ever returns this. Any questions, or what questions do you have about recursion? Is there anything you want me to go over or provide any examples or anything?
In that last example,
This one?
yeah, for how come that's not reaching the base case and announcing liftoff?
Oh, it's
It's
because
in
I'm not
print.
printing it.
Not print.
Sorry.
Oh, it's returning liftoff. Never mind.
Yep.
Okay.
Sorry. Let's do that again. So liftoff, and if I comment this out, and just to make sure that this is actually in fact working, come down here, clear, liftoff. Yep. Yeah, it's just because I wasn't printing it. If I returned like a print statement like that, then I would be able to work it. What other questions do you have? So it's almost like another example is like a dream, like Inception. If you've ever seen the movie Inception, a dream within a dream within a dream. Like each dream is a function, and so you're dreaming, you're in one function, and then inside that one function, you start dreaming again. So you're inside of another function, inside of another function. So you're like multiple layers deep inside of dreams. That's like a recursive case, and then you have to like wake up. Yeah, I don't know, just another example. Cool. Well, it is 11:59. Let's quickly go over the challenges for today. Right here, there's 2 challenges. There's recursion, which is multiple challenges, which you've already have solved iteratively. Some of you have solved them already, like using recursion, or at least some of them. But there's factorial, palindrome, 99 bottles, and Roman numerals. So in here, there's JavaScript and Python. If you just look at the recursion challenge, they're all right here: factorial, palindrome, 99 bottles, and Roman numerals. So just look at how you solved it before. And if you didn't solve it before, just go look at pull requests for those challenges. And there should be solutions to those challenges, and then try to solve them using recursion in JavaScript and Python. And any questions about the recursion challenges? All right. The next is called binary search. This one's actually a pretty difficult one if you've never heard of binary search. So it is a very common interview problem, and it's essentially a searching algorithm to search for a specific element within an array of numbers. So if you had like a sorted list, actually, I want to see if I can. Let's see if I can do something. Iterative search YouTube. I just want to see if this is working. Screw that. There are some visuals as far as, so if I wanted to search through an array of say like 100 million line, an array that's like a million, that has a million elements in it, and it's a sorted list, and I wanted to search through to find like number like 860,000. I'd literally have to start at 1 and go 108, like 160,000. Have to like a for loop that just goes 160,000 times, which would take a long ass time. Binary search is a way to break down that problem and into smaller, essentially into smaller problems. So you're having multiple functions run at the same time, searching through that list until you find it, and it does it substantially faster. So binary search is an algorithm. It's like a searching algorithm that allows you to find values within lists substantially faster than just using an iterative like for loop or a while loop.
So in like JavaScript, I mean, isn't that done exactly with the index of method?
I think it might depend on the length of the list. I'm not quite sure. It depends on, you'd have to look at the JavaScript's documentation. I think like the index of, if it does, do you know if it in fact uses binary search for any length of array?
Well, I was just Googled it, and it just returns the index value of the parameter that you passed in from an array.
Yep. So like
Okay.
it might use binary search underneath the hood, but it might use like just an iterative for loop. It depends on how long the array is. So I think there might be a parameter, like if the array is 10, it'll just use an iterative way approach. When it's over 20 or over 10, it might use a binary search to make it more efficient.
Wouldn't
So
binary
how would
search
that-
only work if the array was sorted beforehand?
Yes. Yeah. So
So how is a binary search different from an iterative or loop?
Keep
Search?
splitting it in half basically, and then if the value that you're searching for is in either half, it discards the half that it's not in.
yeah. So
Okay.
here's the basic premise of the algorithm. Say you're searching for a value, a number of defined, in a search of sorted values. So what you want to do is find the middle part of that array and then split that array into two parts. And if the value that you're looking for is smaller than the middle index, the value at the middle index, then you want to discard the larger array and then essentially pass that smaller array back into binary search. So you're going to call binary search again. So it's a recursive function. And at that point, you're going to, again, break that one down into smaller and smaller until you find it or you don't. So yeah, so find the middle value of the sorted array, we'll call middle value. If the number to find is equal to the middle value, then you found the target value. If the number to find is less than the middle value, split your sorted array in half and then pass that split array back into the binary search on your new subset. So the half of sorted values before the middle value. So like the smaller half of the array. If the number to find is greater than the middle value, you'll pass the bigger, larger array back into binary search. And then you'll repeat that until you find the number or return -1 if it doesn't exist. So yeah, it's a bunch of if statements. If Yeah, if it's the number you're searching for is smaller, you're going to split the array and then pass that array back into binary search. Just keep on doing that until you find it.
The CS50 course, I think
Yeah.
it's like week 3 or week 4. Yeah, it explains it pretty well. It
Okay.
explains linear search, and then I think there's one more as well.
Yeah.
So this is
Nice.
a more of a performance optimization search than a loop iterative.
Correct. Yep. Yeah. So yeah, just try to spend a lot of time pseudocoding. We kind of already pseudocoded it here a little bit for you, but definitely you should pseudocode it on your own as well, or like copy this in and try to pseudocode it in a manner that you might understand. Yeah, this is a really good one. All right. Any questions?
Yeah, I got a question, Tom.
Yep. Josh?
This afternoon's going to be pair programming on these challenges.
Correct.
Okay.
Yep. I'll Slack out the pair programming partners right after this.